Traditional machine learning method vs neural networks, on the MNIST Handwritten Dataset. Abstract. In this paper we compare the accuracies of solving the task of number identification of the MNIST Handwritten Dataset with two types of modeling approaches. On the one hand, we use well-known traditional machine learning classification, which is logistic regression in this case, and on the other hand we use artificial neural networks to do the same. Traditional machine learning algorithms tend to perform at the same level when the data size increases, but N outperforms traditional machine learning algorithms. Three different groups of models are trained. For the entire dataset, to detect to and to detect not to. In addition, we add another hidden layer to the neural networks to offer more insight. Introduction. The MNIST database, Modified National Institute of Standards and Technology database, is a large database of handwritten digits that is commonly used for training various image processing systems. The database is also widely used for training and testing in the field of machine learning. It was created by remixing the samples from MNIST's original datasets. The creators felt that since MNIST's training dataset was taken from American Census Bureau employees, while the testing dataset was taken from American high school students, it was not well suited for machine learning experiments. Furthermore, the black and white images from MNIST were normalized to fit into a 28x28 pixel bounding box and anti-aliased, which introduced grayscale levels. The MNIST database contains 60,000 training images and 10,000 testing images. Half of the training set and half of the test set were taken from MNIST's training dataset, while the other half of the training set and the other half of the test set were taken from MNIST's testing dataset. Method. Methodology overview. The MNIST data is freely available online. It is split into 60,000 training images and 10,000 testing images. The data was flattened and shuffled before it was used for both the logistic regression classifier as well as the neural network. The dataset was also shuffled before being used to train the two models. The code was written using Sklearn, TensorFlow, and Keras in Python. In order to gain a better insight into the difference between the methods, three different sets of models were trained for the dataset. One set was a general model for the entire dataset, the second was to identify just the number 2, and the third was a model to identify not to. In addition, another neural network with a hidden layer was trained in each set. Additionally, each model had k-fold validation done on it with 3 folds. To evaluate the performance of any machine learning model, we need to test it on some unseen data. Based on the model's performance on unseen data, we can say whether our model is underfitting/overfitting/well generalized. This is the reason we have used k-fold cross-validation. Once the models are trained, we then find out their accuracy and find the confusion matrix along with our performance metrics such as precision, recall, and F1 score. The same was done for the cross-validation score and cross-validation predictions. Logistic regression model. The logistic regression classifier was trained using the LBFGS solver and a tolerance of 0.1. Neural network model. The neural networks were trained using the sigmoid activation function, the atom optimizer, and the sparse_categorical_cross entropy loss function, and 5 epochs. They had 10 dense units/neurons. The neural network with the hidden layer had an additional layer with 100 dense units using the ReLU activation function. Results. Before you begin to format your paper, first write and save the content as a separate text file. Keep your text and graphic files separate until after the text has been formatted and styled. Do not use hard tabs, and limit use of hard returns to only one return at the end of a paragraph. Do not add any kind of pagination anywhere in the paper. Do not number text heads, the template will do that for you. Finally, complete content and organizational editing before formatting. Please take note of the following items when proofreading spelling and grammar. Conclusion. After the text edit has been completed, the paper is ready for the template. Duplicate the template file by using the Save As command, and use the naming convention prescribed by your conference for the name of your paper. In this newly created file, highlight all of the contents and import your prepared text file. You are now ready to style your paper. Use the scroll down window on the left of the MS Word formatting toolbar.